All right, welcome back. Today, guys, we're going to do the second day of lesson 8.1.4, starting with core problem 47. So yesterday we did a box plot for the data for those cities from 1975. So if you guys were a little bit unsure yesterday about how to create one, we're going to do the same thing. We're going to review, create a box plot, but now with the data from the year 2000. So I'm going to go ahead and go back to the resource page that has the data for the year 2000. You guys should have it from yesterday. But if not, here it is again today. So notice the 35 sets of data in the year 2000 are already organized for us, least to greatest, which really helps out a lot. Yesterday we talked about how to go ahead and create a new line and plot each of those values. I'm going to go ahead and introduce a different way to you guys. It's the same idea, but I like to go ahead and write out all of my numbers, all 35 sets of data, least to greatest, just like we would on this number line up here. Okay, because for me, it's a different way of organizing the information. So right away, we said a box and whisker plot gives us some information that's useful. Number one, the minimum here is what, everybody? Good, 33.
And our maximum here is
86. So we already have two of the 5 pieces of information we need to go ahead and create a box plot. So using the number line up here, we can go ahead and put our minimum at 33 and our maximum at 86. The other thing we could find pretty easily is our median value, the middle value. So we talked to you guys about crossing off the first and then the last and the second and the second to last and so forth until you guys go ahead and find the median. So while I go ahead and do this, you guys pause it and find the median on your own. So if you guys see, I cross off the first and the last and the second and last, and you guys should have found the middle value was 65. So that's your median. So we're going to go ahead and draw another vertical line at 65. This is the exact same process as drawing, the dots on the number line, but for me, it makes it a little bit more organized. That things aren't so scattered, less likely to skip over numbers. But you guys do what works for you. So in question 47, they asked us to find the minimum and the maximum values in the median. So now the hardest part is finding the first and the third quartile. And it's just because they're new terms for us. So we think about, really we're just finding the median of our, everything to the left of the median. That's our quartile 1. And the median of everything to the right of the median. So let's go ahead and model the lower quartile median. All right, and you guys can go ahead and find the upper quartile. So Miss Lands will cross this out because we're not using the median. So I'm going to go ahead and get a different color. So I'm going to choose a different color. So again, we cross off the median. We do want to include the minimum value, though, as our lowest number. So we cross off the minimum, and then 62, and then 44, and another 62. And again, you're working your way to the middle. And we find out that lower quartile, or quartile 1, is equal to 54. So you guys go ahead and pause the video, and you guys are going to find the quartile 3, or the median of all of our data, to the right of 65, our original median.
okay. So as you can see, we found our third quartile range to be 75, and I hope you guys did as well. So I went ahead and drew our line for my Q3, or quartile range, third quartile range, and I drew it at 75. Now you guys are going to go ahead and make your box. Remember, that's connecting Q1 to Q3.
Also remember that's 50% of your data.
And then you're going to make your whiskers, which is your
horizontal line going from your minimum to quartile 1.
And your Q3 going to your maximum.
And that's where the name box and whisker plot comes from, because they look like whiskers of a cat. So in your 2 whiskers each represent the other 25% of your data. So altogether you have 25% of your data, 25, 25, and 25% of your data. All right, so question 48. All right, so now that we've created box and whisker plots or box plots for those two different years of data, question 48, we're going to let you guys kind of work through, just read the questions carefully. So we're going to use our box plots to measure the spread by doing A, B, C, D, and E. So go ahead and pause the video, take a couple minutes, work through these 5 questions. At the end of that, go ahead and unpause the video. We're going to go ahead and project the answers for you guys, and then we're going to go ahead and move on. All right, so make sure you guys read the directions carefully.
You also have to look at your box plot that you created from yesterday's lesson from 46 and 47.
All right, so if you guys look at the answers here, for question A, you guys will find that 1975 has the greatest range. Okay, its range was 71 as compared to in the year 2000, it was 53. So remember, the range is just the difference between the highest and the lowest number. Question B, they introduced to you guys a new term, the interquartile range, the IQR. And it's just found by calculating the difference between the third and first quartile. So it's the range of your lower and upper quartile. So how we found that was 73 minus 56 to give you an interquartile range of 17. Question C, so practice interquartile range for the year 2000. So 75 minus 54, again, we take the third quartile and we subtract from that the quartile 1. Letter D, now which year of temperature seems to have the most spread? We found out that that was the year 2000. And that's because it has the largest interquartile range. And letter E, what advantages are there in using the interquartile range to measure the spread instead of the range or the mean? So the interquartile range does not include outliers. Okay, so because we can also use the interquartile range then for data that does not have has non-symmetrical distributions. So the last question, 49, says, look at the histogram and box plots of temperatures that you guys have created. Describe the center, the shape, the spread, and the outliers for both sets of data. According to these histograms, what can you say about the temperatures on November 1st in both of those 2 different years? Did the graphs show that one date was warmer than the other, or are temperatures basically the same? Be prepared to share your explanation or your reasoning. So this is one we're not going to work through with you guys. We're going to go ahead and have you guys compare the two tables, the 2 different histograms, and go ahead and tell us what you guys can determine when you guys compare the 2 of them. Thank you for all your work today, and we will see you guys tomorrow.